For our lesson 12, applying the use of sigma notation in finding the sum. The sigma notation is a useful and condensed way of writing the sum of a given number of terms of a sequence. The sigma notation simply indicates the sum of the given numbers in a sequence. Evaluate summation of I squared as I goes from 1 to 3. It means we need to get the total sum of I squared terms from I is equal to 1 to I is equal to 3. First is 1 squared plus 2 squared plus 3 squared. So 1 squared is 1 plus 2 squared is 4 plus 3 squared is 9. 1 plus 4 is 5 plus 9 is 14. So evaluate summation of I minus 1 as I goes from 1 to 5. So let's find the sum of I minus 1 terms as I goes from 1 to 5. So I first is 1 minus 1 plus 2 minus 1 plus 3 minus 1 plus 4 minus 1 plus 5 minus 1. 1 minus 1 is 0 plus 2 minus 1 is 1 plus 3 minus 1 is 2 plus 4 minus 1 is 3 and plus 5 minus 1 is 4. So the total of 10. Rules for the use of sigma notation. If we are given a sigma notation in this form, we can find the sum by simply multiplying the constant with n, which is the upper bound. So for example, evaluate 6 as I goes from 1 to 4. N here is 4 and C is 6. 6 is the constant value. So we will just multiply 4 and 6. N times C is 4 times 6, which is equal to 24. So the sum is 24. This is just the same as 6 plus 6 plus 6 plus 6, which is equal to 24. For the second rule, if we are given a sigma notation which looks like this, we can find the sum by simply multiplying C with the summation of K as K goes from 1 to N. For example, evaluate 3N as N goes from 1 to 5. So let's apply this property. So C, the constant is 3 times the summation of K, where K is N goes from 1 to 5. So it will become 3 times 1 plus 2 plus 3 plus 4 plus 5. So 3 times 1 plus 2 plus 3 plus 4 plus 5 is 15. So 3 times 15 is 45. This is just the same as 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. So 3 plus 6 plus 9 plus 12 plus 15 is equal to 45. So this is just the same. For the third rule, if we are given a sigma notation in this form, so we will just multiply n and c, where n is the upper bound and c is the constant, plus the summation of k, as k goes from 1 to n. So for example, evaluate n plus 3 as n goes from 1 to 5. So n here is 5 and c, the constant is 3. So let's multiply n and c. So 5 times 3 plus the summation of k or n as n goes from 1 to 5. So 1 plus 2 plus 3 plus 4 plus 5. So 5 times 3 is 15 plus total sum of this is 15 is equal to 30. So same as 1 plus 3 plus 2 plus 3 plus 3 plus 3 plus 4 plus 3 and plus 5 plus 3 equal to 4 plus 5 plus 6 plus 7 plus 8, which is equal to 30. This is just the same as this. For the fourth rule, if we are given a sigma notation in this form, we can find the sum by simply adding the separate summation of two functions. It will become summation of f of k plus the summation of g of k. Evaluate n squared plus 3n as n goes from 1 to 3. So let's consider n squared plus 3n as the sum of two functions f of x and g of x. So summation n squared plus 3n as n goes from 1 to 3 will become the summation of n squared as n goes from 1 to 3 plus the summation of 3n as n goes from 1 to 3. And here we are again. We are given this sigma notation. So for our second rule for sigma notation, we will just multiply the constant with the summation of n as n goes from 1 to 3. So in this sigma notation, the 1 squared plus 2 squared plus 3 squared plus 3 times the summation of n, 1 plus 2 plus 3. So 1 squared is 1 plus 2 squared is 4, 3 squared is 9 plus 3 times 6. 1 plus 4 plus 9 is 14 plus 3 times 6 is 18. So 14 plus 18 is 38.